other types of equations. So if you look at these problems here, these are straight out of your homework. What's the highest power that you see here? 4. Is that a quadratic? No. Doesn't look like it. This one is 3. That doesn't look like it. This one is 4 as well. Here's x minus 5 but squared. So what's going on there? So what happens when it looks something funky monkey? So I'm going to talk about how to do U-substitution. So U-substitution means that you're going to substitute something ugly in here to make it look pretty. So I call U stands for ugly, but it doesn't. But I just how I remember it. So you're going to substitute something ugly to make it look pretty so that you can solve it. So let's take a look at this about substituting something quote unquote ugly. And that's my term, right? But it's really substituting something complex, right? Complicated. Substituting something ugly with something simple. Or I put pretty, right? Or simple. So that it's solvable. In this class right now, what is solvable right now is that we can solve linear equations and we can solve quadratic equations, right? Linear and quadratic equations. So linear equation, again, looks like something with y equals to mx plus b, where the highest exponent is 1. Quadratic equations is anything with a square in it, right? So ax squared plus bx plus c is equal to 0, right? So if you could get an equation in this form, then we could use factoring, we could use square root method, we could use completing the square, we could use a quadratic formula, right? If you get it in this form, then we could solve it. So if we could get it to be an x squared or an x, then we're all good in the hood, right? This is to the 4th power. Do we know how to solve something to the 4th power right now? No, right? All we know is to the 1st power and to the 2nd power. So how do we solve something to the 4th power? Well, that's the ugly part, right? So in my mind, I'm thinking ugly, right? Because I don't know how to do this. So I'm going to replace this x to the 4th with something that I do know. So I want this to be something to the 2nd power, right? So I'm going to substitute. So substitute. I'm going to do U-substitution. And this is the beauty of math. You can make it look like what you want it to be as long as it's following the right rules. And U-substitution, if you go to calculus, you're going to use this in calculus a lot. Because calculus is complicated, but you can make it look pretty. Right? Once you make it look pretty, you're like, oh, I know how to do this. So what I'm going to do is my goal is I want to make this look pretty. So I want this x to the 4th to be something to the 2nd power instead, right? And I'm going to just call it u. I want this to be a u squared, right? I want that to be a u squared. I want minus, so if I want it in quadratic equation form, I want u squared minus, I want this 8, the 8's going to stay the same. The x squared, I want that just to be a u minus 9 is equal to 0. I write down what I want, and I'm going to work backwards, right? So sometimes you got to start with what you want, and then you'll know what work you got to do, right? Start off with what you want. So if I want this, how am I going to make this true? I'm going to do U-substitution. I'm going to I'm going to say let u equal to, what does u have to equal to in order to keep this kind of the same? Let u equal to what? X squared. Let u equal to x squared. Then therefore I could substitute, hence the word u substitution. I could substitute u in for x squared. Does that make sense? the name explains what you do, right? You're substituting the u in for the ugly part. However, this only works if and only if when I square u, because there's going to be u squared, right? If I squared this term here, x squared, it better give me x to the fourth. If it doesn't give it to me, then it does not work, right? So if I squared u, so if I decide to square this dude, square this, and that means I have to square this guy, x squared squared. If I square this, what's x squared squared? X to the fourth using the power rule of exponents. And is that the case here? Does u squared equal to x fourth? It works. It works. Happy face, right? If, suppose I squared it and had x to the fourth, but this here said x to the fifth, then it doesn't work, right? So you can only, we're substituting u in here, but it has to work with all of the u's in here. So if u is x squared, then u squared must be x to the fourth, right? So it has to work in order for you to substitute it in. Do you guys have any questions on that? I know it's kind of, if it's a new concept, so first start off with what you want and see if it'll work. So if you want this to be this, let that be that. You can let it be anything you want. In this case, you want it this. But it only works if you squared this term, the u squared, then if you square this, it becomes x to the fourth. It becomes this term. All right, so this is u substitution. I'm going to put this in brackets of what we just did. And I'm going to say what we did. The substitution, I'm going to box that to remember what the substitution was. So now I am left with, so therefore now I have my goal. I have u squared minus 8u minus 9 equals to 0. Now I'm dealing with something that is familiar. That's pretty. Can I solve this? Mm-hmm. I sure can. So when we factor this, what do we get when we factor it? U minus 9. U plus 1. Does anyone need me to work out how this happened? Everyone good? No shame in the game? Yes? Yes? Okay. So here's a side work. I'm going to do u squared minus 8u minus 9. Two terms that multiply to give you u squared are u and u, right? What are two numbers that multiply to give you 9? 9 and 1 or 3 and 1 and 3 or 3 and 3, right? There's only two options. One of them is going to be negative. We don't know which one. Cross multiply, I get 1u and 9u. Can I add or subtract that to give you negative 8u? Yeah. Where do I need my negative? At the 9. So if it's a positive 1u and a negative 9u, I will get negative 8u. Winner, winner, chicken dinner. That is negative 8u. So where do I need my negative, on 9 or 1? 9, right? So therefore, when you box it, you end up getting this right here. So this is X box. All right, and again, if this is going too fast for you, or you're like, what? How does they do? I'm still stuck on Xboxing. This is where videos at home, and there's lots of homework on Xboxing and that you could practice at home. All right, so after I factor, what do? The ZPP, right? We're going to solve this using the ZPP. So I'm going to set each one equal to 0. I'm going to solve for this. Add 9 to both sides. We get u equals to 9. Add negative 1 to both sides to get u to negative 1. Any questions? Am I done? Right? 9 and negative 1, we're good?
No.
Why not? Why am I not done with this problem?
Because the u is equal to x squared, whatever that is.
Right. We need to solve for x. So not done. We need to solve for x. That's the point of the problem, is to solve for x. U is just to substitute it in, just to make it look pretty. Because we can't solve this as is, but when we substitute it to make it look pretty, we have it in quadratic form, and we can solve a quadratic. But now I need to solve for x, right? I'm like, oh, okay. Well, thank you very much, U, for making it look pretty. And now I know what you are. Yes, pun intended. I know what you are, but what is x, right? What is x? Well, there's a relationship between U and x. What's the relationship?
U is equal to x squared.
Oh, okay. So there's a relationship between them. If I know what U is, can I find x?
Mm-hmm.
I sure can. So now find x. So the relationship between U and x is that box right here. U is equal to x squared, right? That box, and that's why I boxed it, so that I could remember what's the relationship, right? So if U is equal to 9, what's x going to be?
3.
Okay. So here,
Plus minus, right?
so I get 9 is equal to x squared. Right, I plug the 9 in for U. 9 equals to x squared. How do I solve for x? I'm going to
Square root.
square root both sides. If I square root both sides, what do I need when I square root? Plus or minus. So what is x equal to? Plus or minus
3.
3. Because the square root of 9 is 3. Okay. Let's go ahead and do that with U equals to negative 1. Right? So if U equals to negative 1, go ahead and try that. What do we find out when we plug in negative 1 in here?
Isn't it like...
Right. Can you square root a negative 1?
No.
I need a plus or minus. Well, if we're working in a complex world, we can. What's the square root of negative 1? I. So therefore, x is equal to plus or minus I. So now that we have access to the complex world, we have a solution. So how many solutions are there? Not 2, but 4. 3, negative 3, I, and negative I. What's the highest power?
4.
4. That's why there are 4 solutions.